I would like to request Professor Lalu Prasad Paudel to chair the session, Dr. Susmita Bhandari to co-chair the session, and the rapporteur is Sunil Lamsan. I would like to request Kaviraj Paudel for the first presentation, a decade of.
So we are now in third technical session in this hall today. This is the last technical session before dinner, and we have 7 technical papers in this session. One paper is special paper and other papers general papers. And my co-chair is Dr. Susmita Bhandari and rapporteur is Mr. Sunil Lamsan. So we are going to start the first paper. The first paper is by Kaviraj Paudel and co-authors. A decade of discovery, tectonics and geological evolution of Nepal's Lesser Himalaya, the Jugedi Gorkha corridor of Western Central Nepal is the center for academic research. So Dr. Paudel, you have 20 minutes for this presentation.
The topic of the presentation is a decade of discovery, tectonics and the geological evolution of Nepal's Lesser Himalaya, the Jugedi Gorkha corridor of West Central Nepal is a center for academic research. And till now, there is a contribution of a large number of researchers to refine the geology of this section. And recently, in this decade, we have carried the students from Central Department of Geology to show the geology in this section. And what are the major things that we show to the students is explained here. Actually, this location is near from the Kathmandu, one thing, and other things, the structurally as well as from other aspect, the geology, the area is typical with several features. Okay, and Kathmandu Paudel, our convener, and Lalu Prasad Paudel, chairperson, are also co-author of this paper, including several co-authors. I am grateful towards all those co-authors. Okay, introduction. The Jugedi Gorkha section of West Central Nepal is a part of the Lesser Himalaya, a geologically important region. This region has the main boundary thrust MBT, well exposed at the Jugedi section southward, and the main central thrust Yangsti at the north of Gorkha, Bazar and Besi Shahar. And this area consists of the rock succession belonging to the Nuakot group and Bhimhedi group as we compare to the central Nepal. And the western closure of the Mahabharata Synclinarium, the eastern closure of the Gumauni Ramjakot Synclinarium, a tight Brahman Besi anticline, and the full spectrum of the Gorkha Kunsa anticlinarium are well developed in this region. And the area is rich in both primary and secondary structures as well as mineral resources. And this is the study location that covers the parts of the Tanau, Gorkha, Lamjung and Navalparasi districts between Jugedi and Gorkha Besi Shahar sections. And this location map is shown in the tectonic map of Central Nepal, modified after Paudel and Arita 2000. And look here, and in this study area, interestingly, this is the Kathmandu Nap, this is Muglin area, and there is Jajarkot Nap, and in between these two permanent naps, there is one Kaunkhilipe. So within this region, the rocks of the Bhimhedi groups within this Kaunkhilipe and the rocks of the Nuakot groups, this is supposed to be autochthonous successions in Lesser Himalaya, are found. Motivation. The major motivation consists the Jugedi Gorkha section serves as an important reference site for studying Himalayan tectonics, stratigraphy and structural geology. The well-exposed folds, thrust and rock succession make this area a valuable field location for the geological research and academic studies. And the Kaunkhilipe, I already explained, is in between these two major naps. And the methodology, mostly a geological map was carried out in 1:25,000 scales. And a number of geological excursions are carried out in this section with students, with faculty members, and with some international researchers as well. And finally, petrographic analysis, metamorphism, deformation, and thermobarometries are also carried out in this section. And I go to the results and discussions, and this is the most widely accepted stratigraphic classification of Lesser Himalaya in central Nepal, and this Kuncha with several members, and Kakpo, Danagao, Nurpur with Purevesi quartzite, Dhading dolomite, with the beds, and then suspicious unconformity, Benighat, Malikurwan. This is the most adopted stratigraphy proposed by Stockley and Bhattarai in 1977. And during the geological mapping in 1:25,000 scales along the strike, we have revised the stratigraphy, Paurel and Paurel 2011, Kuncha formation, and no more members are found within this Kuncha formation in this section. And actually the Ampu quartzite, it is supposed to be uncertain stratigraphy of quartzite succession within Kuncha formation is finally joined with the Kakpo quartzite if we carry out the along strike mapping in this area. The section lies within the road corridor, that's why everyone can go there and see it. And similarly, Lapti phyllite joins with the Danagam phyllite, and Purevesi quartzite joins with the Banspani quartzite. And Nurpur formation has developed several members in this succession, and this is the revised lithostratigraphy of these successions. And additionally, this is the calcareous outcrop of the Kuncha formation and metaconglomerates as well in the upper part of the Kuncha formation. There was a concept that the lower Nuwakot group is non-calcareous and upper Nuwakot group is calcareous. This was the concept given by previous researchers, which is not valid in this section. And let's talk about the Nurpur formation. It consists of several units. The lowermost one is Purevesi, followed by Amdana phyllite, laminated succession, Lapti-Kola member, pink succession with ridge in sedimentary structures like mud cracks, several types of ripple and several metasandstone beds and amphibolite, metabasites, beds, etc. And the youngest one is the Bandipur slate. This is also a part of the Nurpur formation in this section. And another debate is in the contact between the Dhading dolomite and Benighat slates. There was unconformity, but in these sections, look here, in Jugedi section, Bhutkola, Lapti-Kola and Bagarkola sections, there is a perfect transitional contact between the Benighat slate and Dhading dolomite, representing in this section the concept of lower and upper Nuwakot group is not means valid. And let's talk about the Khao Kilipe, and the Dubung thrust carried the rocks of the Khao Kilipe equivalent to the Bhimpheli group in central Nepal, and this is Dubung thrust. It carries the rocks of carbonate succession, marble at the bottom, and followed by, this is mapped as the Guaslung formation, and then quartzite and schist succession. This schist consists of garnets, and finally another schist unit with again the garnet grade of metamorphism. Look here, these are the outcrop pictures, and if we try to compare with the stratigraphy with central Nepal with Kathmandu Nepal, then the Sivapur schist resembles closely with the Rodua formation. If so, in this case, these two successions should be older than the Sivapur schist, these two successions. And from this we can infer that the Mahabharata thrust or equivalent to it has got deeper when we go to the western part of the Himalaya and shallower depth to the eastern part. And this is the geological map that we carried out, and this shows the Gumauni Ramjakot Centenarium, and the rocks of the Khao Kilipe occupy at the central part in the western side. Look here, and if we prepare a generalized geological stage, look here, we can see the MBT at the Jugedi section and sub-Himalayan rocks, this middle Shivalik with plant sources, plant leaves are here. These Siva leaves ultimately from MBT give rise to the rocks of the lesser Himalaya, mostly the thrust zone and then equivalent to the Dhading dolomite because it has columnar stromatolites, and then again another thrust, this Devachuli thrust, and it carries the rocks of the lower part of the Norpur formation, and there is a broad Gumauni Ramjakot synclinum. The axis passes from here, and at the Bradum basin there is anticline, and then we can see the Jalvire syncline. This is the western closure of the Mahabharata synclinum. So there are two conjugate large synclinums separated by the Bradum basin anticline in this section, and then there are several cycles of anticline and syncline from the Mughal area to the Abu Ghairani area to the Bimalnagar, Dumre to the Bandipur section. In Bandipur actually there is again syncline, but here from Dumre we move to the Bhoteodar anticline. At the core of this anticline we can see the garnets in the Tunja formation, and then the northern limb of this anticline starts and the metamorphic grade decreases. Again at the Yamsiti zone again there is inverted metamorphism, and then Yamsiti carries the rocks of the higher Himalaya in this section. When we talk about the this Bandipur from Dumre, the structure is so complicated, and there is Bimalnagar syncline and Dumre incline, tight antiform is over there, and the Bhangeri thrust, this is south dipping thrust, carries the rocks of the Norpur formation over the Dhading dolomite, and then again there is syncline, and at the core of the syncline there is the outlier of the Dhading dolomite with the columnar stromatolites. So this is the overall geological framework in this area, and we show and teach the students those things over there. And this is the geological map from Dumre to Besisahar section. And within the Marsandi river section, we can see several shades of river terraces. This is really wonderful. If we see the river valley of Tirusuli, no terraces. There is a gorging, there is a down cutting of the rivers. But adjacent to the Marsandi, there are several shades of, look here, the terrace deposits. So the geomorphological implication is something there. So this was, and now I move to the metamorphism. Basically, two types of metamorphism we can see. One towards the Yamsiti zone. This is seen to post-tectonic metamorphism because garnet represents clearly the post-tectonic metamorphism, but the garnets within the rocks of Council is pre-tectonic. So two types of metamorphism is there, and here metamorphic zonation, and look here, this is the pre-tectonic garnet within the rocks of the Council, and seen to post-tectonic garnets in the Yamsiti zone near the Choprak area, and north of this, and north to the basis of the region as well. And if we see the metamorphism, we can see the very normal and boreal metamorphism in the rocks of the autochthonous units. But at the the footwall of this thrust sheet, we can see the inverted metamorphism. So this is another type of metamorphism in this region. Now I move to the magnetism. And if we see, we can see several positions of metabasic rocks within the succession. And from Jugedi to the Marsandi hydropower dam, we can see three positions of metabasic rocks and one metabasic rocks within the Roban formation in the Malacca area. And so we see the field relation of these metabasic rocks with the host rocks in the study. Look here, in the Gumauni area, there is concordant relation with the metabasic rocks with the phyllite and metasandstone successions. And but look here, this is interesting, and the recent findings. There is cross-cutting, discordant contact with the metabasic rocks with the host rocks. And look here, these are two. And this is cross-cutting relationship. This is the stratigraphic position. And we see such type of discordant positions in Moulin section as well as Abu Ghairani section. So there are both concordant as well as discordant field relations with these metabasic rocks. This is the mineralogical variation within the metabasic rocks, and there is slight variation within all these metabasic rocks, and the further study is under the way. And this is the mineral resources map prepared Podial et al. 2013 in this area, and interestingly, this area consists of both non-metallic as well as metallic mineral resources, and this area is very rich in mineral resources, and to teach the students, this acts as a laboratory, this field, and these are some field photographs showing the Bandipur slate, copper mineralization, iron mineralization in this area. And this is the one book recently published by the Central Department of Geology, where I am author, and mineral resources of the Bhutkhola, Lakdikhola, Bandipur area of Tanaung district after this long field work and researches. Now I finally go to the some of the unsolved questions and ongoing discussion with faculties, researchers and students, issues on carbonate succession. Look here, in the southern part we have wonderful stromatolites in the rocks. Here, stromatolites look here in the southern part, but in northern part the same carbonate successions are laminated, and there are several partings of peritic rocks. And in the Gumauni area, the thickness of these carbonate rocks is quite pinching, and thickness goes up to the 3-4 meters. That's why in our mapping scale no carbonate appears. That's why this has created some problems in field mappings with the carbonate rocks. Another issue is on stratigraphy. In the Bimal Nagar, everyone you travel to go to the Pokhara, in Bimal Nagar there is a huge succession of the dolomite. But if we see the left bank of the Barsandi, you can see the rocks of Puncha, and in the right bank you see directly to the rocks of the Dhading dolomite. So is there any unconformity or anything? Beds are right side up, so this is the another major issue in stratigraphy. And similarly, another issue is on the Bandipur slate and Bhangeri thrust. This Bandipur slate is mapped at the top part of the Northwood formation. Actually, in previous studies, these are mapped by some researchers to the Benigar slate and like this. So still the debate is ongoing. Because there is one Bhangeri thrust, look here, this is south dipping thrust. This may be back thrust either, or it may be overfolded to the normal, means thrust, means dipping to the north. So there is still question whether it is back thrust or there is some rotation of this parallel thrust. This is another issue, and there is room to study now. And another issue is the contact between the Dhading dolomite and Benigar slates. Look here, everywhere in this section there is a transitional contact. If so, we have a question. If it is valid everywhere, let us think to review the concept of upper and lower Nuwakot groups. So every time we follow this, but we see the transitional contact in this area. Finally, the field relation of metabasic rocks. There are both syngenetic formation and intrusive origin. So what are the major geological events to describe these both concordant as well as discordant contacts of these metabasic rocks? This is another issue in this area. Finally, I came to the conclusion. This region is emerging as a key academic hub for comprehensive geological research, and it is an important type section for studying rock types, stratigraphy, depositional environment, structural geology, thrust tectonics, microstructures, deformation, metamorphism and mineral resources. This looks like a laboratory to teach the students and discussions among the researchers. Okay, the area features well-exposed Himalayan duplex structures with major thrust, including MBT, MCT, shoal and root thrust. The Geological thrust acts as an imbricated thrust, and the Bhangeri thrust may act as a back thrust in this region. And research activities led by the Central Department of Geology, Tribhuvan University, along with faculty and students, are ongoing to enhance the understanding of the region's geological evolution and tectonic history. There is still vast potential for further research, and significant progress is expected in the next decade to address unresolved geological questions from this region. Thank you for your kind attention.
Thank you, Dr. Paudel. So we have time for one or two questions.
Is basic rock is included in the Calcareous system?
No, sir. In this section with quartzite.
Only with quartzite.
Ghost.
No intrusion in calcareous system in whole area.
But in this section, these metabasic rocks. Now it is metamorphosed already.
Yeah, I agree with
Yeah.
you.
And the rock succession, major rock body is quartzite.
Okay.
Yeah, where there is the discordant relation. But in case of concordant relation, there is phyllite, metasandstone, and somewhere calcareous rocks as well.
Try to see the calcareous system. If intrusion is there, then you can get at least wollastonite or something else as an economic significant point of view.
Okay, thank you very much. But interestingly, linking with your query, there is a metabasic, polymetallic deposits within the metabasic rocks, and it is the contact.
Sort of metasomatic.
Yes, we can see it. Yeah. Thank you.
No more questions. Okay, so thank you, Dr. So we move to next presentation by Bharat Raj Banta, Megaraj Vital, and Kundar Pavel. Backforesting and fall propagation folding in the lesser Himalaya of far western Nepal.
Good afternoon, everybody. Best statement. So, it's me, Bharat Panta. I am going to present here for the geological study. My title is Backforesting and fall propagation folding in the lesser Himalaya of far western Nepal. The study area is between Seti River at the east and the Mahakal River at the west, between two rivers. There is the Baitari and Durandra district. This is the study area. It occupies about 1900 square kilometers. This is the geological map of far western Nepal showing major geological divisions. Here are some Klipe, Kochoni Klipe, and this is the Gandra Klipe, Bazan Klipe. The geological map prepared by DNG. This is the recently published map. Basically, here are slate, quartzite, molten sandstone. Here are some different vertical fault. This is the present study about around the Baitari area. This is the cross section, north-south cross section. At the northern part, Baitari carbonate groups, and the middle part, Salina formation, having slate and quartzite intensely folded, and the southern part, the north Dhanadra thrust, and south of that thrust, Dhanadra crystalline group, and between Salina formation and Dhanadra thrust, there is young sedimentary rock thrusting groups. This is the technology stratigraphic columnar section. Oldest rock is Baitari carbonate group. Baitari carbonate group consists of dolomite limestone, slate, having magnesite deposits, and columnar and domed stromatolites. Just above this, there is Gandhari formation, pink purple limestone and slate intercalation, and then Salina formation, slate and quartzite, After there is disconformity and young sediment rocks of Miocene, Paleocene, Eocene succession. Two sections, in upper part Suntar formation and lower part Swap formation. Suntar formation including red purple shade and Swap formation includes mudstone, limestone, cruciferous sandstone with pebbly sandstones. And there is a north and the thrust. Upper part is covered by north and the thrust. Having this is the Gandhra crystalline group, schist, amphibolite, quartzite, and some into the pegmatites and granitic influence. Detailed columnar section of salina formation. There are slate and quartzite infiltration. Slate green grey with laminated sandstones, and quartzite are limited as well as massive quartzite. Actually, these are quartzite sediment rocks, and this is the swap formation. It consists of the conglomerate beds with sandstone matrix, brown shale, green grey sandstone, limestone, purple siltstone, pink purple siltstone. The limestone has fossils of foraminifera, bivalve in the mudstone, fossil of foraminifera in limestone. This is the columnar section, detailed columnar section of Gandhra crystalline group. It consists schist phyllite with some quartzite bands having amphibolite bands. Detailed map of west part of the study area is India and Nepal, Kathmandu Nepal, and at southern part Gandhra crystalline group. Upper part consists of watery carbonates. These two sections come to the very near, whereas the eastern part, this slate and quartzite salina formation exposed widely, but at the eastern part near City River, Ganga, West City project area, also upper carbonate section and the southern Gandhra crystalline group, they also come together. In this type, there is a tectonic window. Some sediment structures, mud cracks, some cracks in sandstone, show the inverted river, inverted beds, and these are the pebbles, limestone in shale, gravel beds in sandstone, cross beds showing inverted beds. Fossils found around this area, foraminifera fossils, these two are an specimen and these two are the thin section. Some selected small scale fold scales. Recombinant fold and some isothermal fold are present here. Folds not only in sandstone but also in dolomite. Photograph of small scale folds, different types of folds. Fold, adjuvant fold, imbricated fold, and inclined fold. Structural analysis of building, coalition and small scale fold from study area, mean building coalition plane. Total data 4,274 and the mean building is 10 foot 358 deep angle and deep direction around study area. Two axial planes and the hint of fold, small scale fold. They are trending northwest to southeast, gently plane plunging. In different area, stratigraphic position were made by the coalition plane, and the eastern area, these are coalition plane trending stack of coalition plane northwest southeast, but in the western part it trend the stack southwest northeast, and the southern part position stack dipping towards south. Evolution model of the study area. This carbonate, with the carbonate group, carbonates and upper part selena formation, star formation, Sunda formation. These are young green rocks, and from north part there is the Delta crystalline Thirsi moves towards south, and finally different types of faulting, and finally the back thrust or myocardial thrust develop. In this situation, fault propagation mode is developed. Lesser Himalayan sediment rocks of study area contain sediment, sandstone, shale, slate, dolomite, quartzite, schist, gneiss and lepidolite. North Rendra thrust over at the Wetted carbonate and other sediment rocks. Wetted carbonate are overturned throughout the study area and back thrusted. Salina formation consists of strongly deformed slate and quartzite in transport coalition. The transport coalition was developed during the multi-phase deformation of the region. The area also consists using fossil spotlight bearing carbonates, salt, as well as moving sand, deposit, and some iron ores.
So we are on time. We have some time for questions if you have. I think we don't have any questions. Thank you. Thank you, Bharat. Thank you for the nice presentation. And we move to next presentation by Purushottam Adhikari, Gaurav Srivastava and Kumnaran Paudel. Plant fossils from the Shivalik succession of the Nepal Himalaya.
And present topics in plant fossils from the Shivalik successions of the Nepal Himalaya. This is the presentation's outline. First of all, Shivalik flora is important in understanding the vegetation shift and the origin of Himalaya vis-a-vis climate changes. As we know, the fluvial successions of Shivalik group is divided into three subunits named as lower Shivalik, middle Shivalik and upper Shivalik. In the lower Shivalik and middle Shivalik sediments of western Nepal, Adventine plant fossils have been identified in forms of leaf, woods, pollen and spores. But few flora records are recorded from the Shivalik sediments of central and eastern Nepal. And so in the present study, we have to identify plant megafossils in Naredi River to Mechi River in different 8 major localities as Sepang Highway, Lothar Khola, Bakaya Khola, Bagmati River, Muksar Khola, Chatara Barakshetra area and Kankai River sections. This is the some of the flow chart of the present study result. In overall, 30 species comprising of 26 genera to 15 family of pteridophytes and angiosperms are identified. However, in comprehensive list comprises one species of pteridophyte family, two species of two monopod families, and 27 species of 23 genera from 13 dipod family, which are, first of all, this is the fossil species of Dactyophyllum tetradium of the family Telepteridaceae, and the nearest living relatives of these fossils is Cyclosaurus proliferus. This different color of arrow are comparison between modern flora and fossils species to help identify. Another is the Amazonian species family Eritaceae. Nearest living relatives is the family Eritaceae. And another is the fossil species is Clinogyne ovustus of family Marantaceae, and nearest living relatives of the Clinogyne grandius. And another fossils is Mangifera somesorica of family Anacardiaceae. Nearest living relatives is Mangifera indica, and another is the Mitropora sivarica of the family Anonaceae, and nearest living relative is Mitropora magini. And another is the fossils is Eunona myosinica of family Anonaceae, and nearest living relatives is Eunona longiflora. And this fossils is Calyophyllum suricolensis of family Calyophyllaceae, and nearest living relatives is Calyophyllum polyanthum. And this fossils is Combretum saini of family Combretaceae, and nearest living relatives is Combretum tocantrum. And this fossils is Terminalia paleotubula of family Combretaceae, and more nearest living relatives is Terminalia tubula. And another is the fossils of Terminalia pantharensis of family Combretaceae, and nearest living relatives is Terminalia tomentosa. And another is fossils Anisoptera paleoscapula of family Pterocarpaceae, and modern comparable species is Anisoptera scapula. And this fossils is Dipterocarpus sivalicus of family Dipterocarpaceae, and modern comparable species is Dipterocarpus turbinatus. And this fossils is Soria robusta of family Dipterocarpaceae. Nearest living relatives is Soria robusta. And this is the fossils of Soria sivarica of family Dipterocarpaceae, and modern comparable species is Soria asamanica. And this is the fossils of fruit wings of Soria of Dipterocarpaceae of family, and nearest living relatives is Soria robusta. And this fossil species is Procoracea nepalensis of family Procotiraceae, and nearest living relative is Procoracea romingi. And this fossils is Xylosma nepalensis of phylum Procораceae, and nearest living relative is Xylosma clastinium. This is the fossils is Alvesia sivarica of family Fabaceae, and nearest living relatives is Alvesia levet. This is the fossils is Bonia sivarica of family Fabaceae, and nearest living relatives is the Bonia purpurea. This is the fossil species of Cyanometra sivarica and of family Fabaceae, and modern comparable species is Cyanometra polyandra. And these fossils, another is fossils in the Cassia nepalensis of family Fabaceae, and nearest living relatives is Cassia fistula. This fossils is Cinnamonum nepalensis of family Lauraceae, and nearest living relatives is Cinnamonum opticifolium. This is the fossils of Daphnogen mokumensis of family Lauraceae, and nearest living relatives is Cinamonum tamala. This is the fossils of Lagestromia himalensis of family Lythraceae, and nearest living relatives is Lagestromia parviflora. This is the fossils of Perigota paleolata of family Malvaceae, and nearest living relatives is Perigota alata. This is the fossils of Artocarpus nepalensis of family Moraceae, and nearest living relatives is Artocarpus heterophyllus, and another is fossils is Artocarpus sivaricus of family Moraceae, and nearest living relatives is Artocarpus tonkinensis. This is the fossils species of Ficus bicunia, and modern comparable species is Ficus cunia. Another one is fossils is Randia myowalici of family Rubiaceae, and nearest living relatives is Randia walici. And this is the fossils of Xanthoxylon species of family Rutaceae, and modern comparable species is Xanthoxylon melandorachis. These all of these fossils are identified, and overall zeolic fossils assemblage, the most dominant family is Dipterocarpaceae, followed by Fabaceae, Moraceae, and Cuprataceae, and other is one species. And this data shows the most dominant forest is evergreen to moist deciduous and evergreen forest during the deposition period of zeolic successions. However, in the lower zeolic fossils assemblage, one is Procuraceae and Fabaceae are most dominant, but only two taxa and another family is just one taxa are identified. This data shows that the most dominant forest in the zeolic sediments of evergreen forest, and followed by evergreen to moist deciduous and mixed deciduous. Similarly, in the middle zeolic flora, the most dominant family is Dipterocarpaceae, and followed by Fabaceae, after that Lauraceae, Moraceae, Anonaceae, Cuprataceae, and other taxa are only one identified. This data shows that the most dominant taxa are grown in evergreen to moist deciduous and evergreen forest during the deposition period of middle zeolic. However, and the Fabaceae family indicates an increase in temperature with warm climatic conditions. The Ericaceae family indicates a high water availability. The tropical taxa such as Mangifera, Anisoptera, Soria, Cinamonum, Perigota, and Artocarpus, Ficus, these all taxa indicate a tropical to subtropical evergreen rainforest, and many of their species are adapted to warm, humid conditions. And Lagestromia of Lythraceae family indicate that it requires a mean annual temperature of 14 to 27.7 degrees Celsius, and it's grow in monotypic evergreen rainforest with warm and more humid climatic conditions during the deposition period. In total, 30 species comprises of 26 genera to 15 elements of study area. The Dipterocarpaceae family exhibit a higher species diversity, followed by Fabaceae family, Cuprataceae, and Moraceae family, Anonaceae, Procuraceae, Lauraceae family, and other. All over, the quantitative data indicates the dominant of tropical to subtropical evergreen taxa in the lower zeolic, and tropical to subtropical evergreen to moist deciduous taxa in middle zeolic sediments. Thank you.
Thank you, Pudusottam. We are on time and we have time for a few questions. Any questions?
Pudusottam, actually I am not planning, but I saw your work very compact and I like it. Your effort is really appreciated. So thank you very much for this precise and compact research. And actually, now I concern in plant fossils, is there any index fossils that you carried out? One question. And another, how many species that we found are still alive and exist today and extinct already? So can you explain about it?
These all fossils are living fossils, not index fossils. And only two taxa are not found in modern flora from Nepal Himalaya. These are disappear due to the upliftment of Himalaya, and another is the not suitable climatic conditions. These one are Gallophyllum polyantha and another is Dipterocarpus. These are not found in modern flora of Nepal Himalaya, but all after two taxa, all are living in modern flora of Nepal
Other
Himalaya.
species are still alive.
Any more questions? I think no more questions. So thank you, Purushottam.
Thank you, thank you.
We move to our next question, Himalaya between Kalikot and Humla, West Nepal. You have 15 minutes and we will give the reminder on 30 minutes.
Any engineering. I'm presenting my research in geology, in topic geology of inner glacial Himalaya between Kalikot and Humla, West Nepal. This is a study area of my research area. Geological research has been carried out in the Tectonic Indo part of the Kalikot, Bajra, Mugu and Humla district along the Kanai River. The area lies in between, comprising the low-grade meta-sedimentary to the high-grade metamorphic rock of Eastern Himalaya and Higher Himalaya crystalline. Many researchers has been conducted in this area to prepare the detailed stratigraphy of the mid-western Nepal in regional scale, which lack the great deal of information. I am trying to conduct the detailed geological mapping and stratigraphy and geological study of this inner glacial Himalaya. Various researchers including Sestra et al. 1987, Woods 1977 and 1980, Ita 2015 and 22 have worked in West Nepal in regional scale and attempt to make stratigraphy of the West Nepal. The present area has not been mapped by any author except Woods 1977. However, this research is in this small scale and not cover the detail on the present study area. 2022 has conducted a comprehensive study in the West Nepal and the stopping 1980, Sakai 1983 and 1985 prepared the detailed stratigraphy of the central Nepal. However, the detailed stratigraphy of the mid-western Nepal is still sketchy. Therefore, to fulfill this research gap, the research has been conducted in the area between Kalikot and Humla. Result of my study is the study area can be mapped in glacial Himalaya sediment sequence, glacial Himalaya metamorphic sequence, and high Himalaya crystalline. The units are separated by parallel thrust and density from north to south, respectively. The regional incline was observed in the area which axis passed through Paima region. Small scale holes around this section is glacial Himalaya thrust has been mapped. This is the cross section of study area from north to south, and this is the anticline from north to south. Detailed stratigraphy of the project area is shown in this figure. The oldest rock is grey green phyllite and meta sandstone, pale yellow quartzite, grey dolomite and slate, black slate. This unit is lies in the sedimentary meta sedimentary sequence. Calcareous quartzite and marble, granite schist and quartzite, white gray and gray and white quartzite. Quartzite is like in the metamorphic sequence, and this higher Himalaya is separated by main central thrust. Lesser Himalaya sequence is occupied in the core and surrounding region of the Kawadi anticline. The anticline is the part of the Gala tectonic window. It is complicated to follow thrust, being the low-grade meta-sedimentary sediment over the sediment rock. The litho unit is described in grey, green phyllite and meta sandstone, grey leather quartzite, grey dolomite and slate, and black slate. Grey, green phyllite and meta sandstone is observed in the part of Shapa, Kawadi and Paima area. It consists of grey, green phyllite, gritty phyllite intercalated with meta sandstone. The thickness of this unit is about 1 kilometer, and phyllite is frequently observed in this unit. Lower contact is faulted and sequence overrides the dolomite, quartzite and slate succession. Due to faulting, various rock succession come in contact with this unit. Granulation and sketchy lineation is well developed in this unit. Pale yellow quartzite, it is one of the most incredible, noticeable sequence in the study area. It is extensively distributed to the north of the Geological and in the Umra Karnali river upstream of Golfagat village. And this unit consists of pale yellow to white grain and white medium to coarse grain, thick bedded to massive orthoquartzite. The thickness is about 900 meter. Cross lamination well and well as well as wavy ripple marks is observed in this sequence. Amphibolite is the frequently amphibolite section is frequently observed in this section. Grey dolomite and slate is transitionally subsists the pale yellow quartzite. It is widely distributed in the Domuka and Jera area. And the gritty phyllite green dark massive stromatolitic dolomite intercalation with strong foliated black grey slate is the main lithology of this sequence. Thickness of this unit is about 4 kilometers. The bed of various color slate, sandstone, and quartzite are observed in the lower part. Branching polymer instrument is observed in this unit. Black slate. It is the youngest unit or rock unit of the sequence. The sequence is only observed in the Humba Karnali river section about 3 km upstream of the Humka. Unit comprises of strongly foliated laminated black slate and some dolomite beds. The thickness of this unit is about 300 meter. Quartz vein is frequently observed in this formation. Lesser Himalayan metamorphic sequence is commonly known as Krishna Nape, whose 1977 and higher Himalayan thrust C data 2022. This sequence is observed from Jera in the north to the Patal Jharna in the south. Bodyguard Parajut thrust is in the north, and MCD in the south is observed there. Granite series, graphitic series, quartzite, feldspite series, marble, and amphibolite are the main rock type of the this thrust series. Multi-polite are observed in this sequence. This lesser Himalayan metamorphic sequence is further classified in the three litho unit, namely light grey to white quartzite, garnet, schist, and quartzite, calcareous quartzite, and marble. Light grey to white quartzite is observed in Y and Tribu area, comprises of very thick bedded light grey, green, pale yellow to white massive quartzite with alternating bed of dark grey phyllite. This thick, the unit is about 1900 meter thickness, very thick, up to the 10 meter band of blue green amphibolite was present towards the lower and upper part of this formation. Garnet, schist, and quartzite. This formation is widely distributed in the study area. Widely cleavage was observed in this formation. Organized, vanillized, and feldspathic schist are observed in this formation. calcareous quartzite and marble. The formation is the oldest formation of the sequence. It is only distributed in the Pilizor and Juti area. The formation consists of village. The MCD separates the underlying lesser Himalayan thrust sheet from the overlying higher Himalayan crystals. This sequence is on the hanging wall of the MCD. The sequence is comprised of the banded gneiss, calcareous gneiss, and organ gneiss. The geological structure observed in this study area is MCD, which separates the lesser Himalayan thrust sheet and higher Himalayan crystalline. Observed at passes low angle south dipping. Vertical thrust separates the lower Himalayan thrust sheet from underlying lower Himalayan sediment sequence observed from near Pilizor. Covered thrust separates the grey dolomite and slate unit with grey phyllite and beta sandstone regionally folded. Hanging wall is comprised of phyllite and beta sandstone. Regional fold great midland covered anticline is observed which hinge line it passes trend which axis it passes thrust pila trend and front is 98 and 25 degree. Discussion and conclusion. I am trying to correlate this little unit with researchers Sestra et al. 1987, Sakai 1983, Stockton 1980, Fuchs 1977. Green grey phyllite and beta sandstone is correlate with Ralimata or Kunsa formation, pale arrow quartzite, grey dolomite and slate having dolomite and marble formation, black slate, Pedigar slate, calcareous quartzite and marble, Domgat formation, garnet schist and quartzite, Melbora formation, I am not sure Melbora formation, Sananigat formation, very nice calcareous, nice and organized.
You have 2 minutes.
Upper Krishna Nabe of Foods 1977. I acknowledge the engineering company and the Bharat company for providing this research. Prakash Mansar, my team leader, and Guru Prasad Adhikari from engineering. Author, I am expressed to share gratitude to Dr. Meghraj Tidal for his kind cooperation in geological interpretation. Thank you.
Thank you, Kishore. We can take a few questions. I think we don't have any questions, so thank you very much.
Thank you.
Now we move toward our next presentation, and the talk is Geological Mapping and Petrographic Study of the Jamiri Gneiss, Eastern Nepal.
The title of my study is Geological Mapping and Petrographic Study of Jamiri Gneiss, Eastern Nepal. Now, basic rocks are present within various geological units, usually in the higher Himalaya of Nepal Himalaya. One of such bodies is present in the outer Lesser Himalaya in the southern part of Bhojpur and Bhankura district of Eastern Nepal. And geologically it lies within the Lesser Himalaya sequence. Previously the body was mapped by Kasyap 1980, Dal 1992, Sumar 1993, Hidar 2015, and Navigator 2023, but it was only mapped for regionally and detailed map was lacking. The body was mapped within higher Himalaya by Hidar 1992 and 2015, while within Lesser Himalaya by rest of the authors. In present study, geological mapping of Jamiri Gneiss covering its extension has been carried out with cross-section study. Detailed route mapping has been performed, and systematic sampling for petrographical microstructural analysis has been done. Now to the geological map, the organ gneiss is shown in the middle portion. The middle formation of this in red color has been shown. It is a lenticular body of gneiss more than 28 km long, and it is underlain by the ochre formation and overlain by Pillara formation. The underlying rocks is present beneath the Jamiri Gneiss is greenish grey to grey calcareous laminated schist, while overlying rock of the Pillara formation is grey to dark grey garnet schist. And the Jamiri Gneiss is myelinitic to proto-myelinitic organ gneiss. From the detailed cross-section and columnar section, two bodies of metabasic intrusion in the form of seal can be observed within gneiss, granitic intrusion, and sedimentary horizon of schist. Three sedimentary horizon of schist can be observed. The underlying rock is the greenish gray to gray schist of ochre formation. This is the representative photograph of metabasic seal within the gneiss. Similarly, the schist horizon present within the gneiss body, granitic seal, and the overlying formation, the grey to dark gray granite schist of the Bellara formation. From the detailed petrography, it can be concluded that the major portion of the Gemini gneiss is composed of alkali feldspar, quartz, and plagioclase. The samples were collected from top, middle, and bottom portion of the gneiss body and was plotted in QAP triangular plot. All of the samples fall within the granite field. In the plot, with the middle portion showing somewhat higher concentration of alkali feldspar compared to bottom and the top portion of the gneiss. Onto the text source, the Gemini gneiss is myelonitic to protomyelonitic with porphyroclast of mostly alkali feldspar and quartz and sometimes plagioclase. The foliation is defined by preferred orientation of muscovite and biotite and flattening of porphyroclasts. The alkali feldspar is mostly porphyritic, genoplastic, and coarse-grained. The quartz similarly is genoplastic, coarse to medium-grained porphyroclast, while the plagioclase is genoplastic to subidioplastic with medium-grained porphyroclasts. The microstructures observed within the Gemini gneiss are indicative of brittle plastic as well as ductile deformation. The brittle deformation can be observed in the feldspar grains, the fragmentation of feldspar grains, which post-date the myelonitic foliation. The plastic deformation observed are ondulous and sweeping ondulous extinction in the case of quartz grains and deformation in plagioclase. Similarly, ductile deformation can be observed as ribbon quartz and grain microstructure, leftover grain microstructure in the case of quartz grains. Similarly, other shear sense indicators such as biotite osmosis can be observed. All of the shear sense indicators indicate up to the south sense of shearing in the gneiss body. Deformation. I have tried to decipher the deformation history of the gneiss. The first deformation stage, named D1, can be seen in the form of bedding parallel foliation in the quartzite within gneiss. Quartzite, thin layers of quartzite are present within the gneiss as in the form of interlayering. These quartzite horizons show bedding parallel foliation. Similarly, the second deformation can be observed in the form of SC structure, the myelonitic foliation, SC structures, and north-north stretching lineation. These stretching lineations plotted show north-north straining. Similarly, the third stage of deformation can be observed in the form of northwest to southeast trending triangulation cleavages and northwest to southeast trending fold. And the final stage of deformation can be seen as in the form of brittle faults and from microstructures, microfractures can be observed in the feldspar grain which correspond to the myelonitic foliation developed in previous deformation. Now, the foliation comparison between the three formations show that the Gemini gneiss shows discordant relationship with underlying ochre formation and concordant relationship with overlying Bellara formation. Now, concluding the study, the Gemini gneiss is more than 20 km long, 1.5 km thick, underlying as well as overlying by schist of ochre and Bellara formation respectively. The boundary varies from transitional to sharp. The gneiss is myelonitic to protomyelonitic with feldspar organs, mostly and composed of quartz, alkali feldspar, plagioclase, muscovite, biotite, and tourmaline, falls within the granite field in the QAP triangular plot. It is comparing the velumillary organ gneiss, and the comparison was it is comparable to velumillary organs and correlation was performed as follows: textural similarity, mineralogical similarity, and similarity in field characteristics, and similarity in the presence of in the characteristics of host rock. Similarly, the tectonic positioning beneath the MCT as per the Summer and Adhikari 1923 respectively of the Gemini gneiss and that of Ulleri organ gneiss in western Nepal has also been taken as the fundamental for comparison. Similarly, the gneiss is thought to be of intrusive origin. The fluid evidences that the intrusive origin are post grain size, lateral and vertical variation in grain size, discordant with the order in presence of tourmaline auriculasts. I would like to conclude my presentation. Thank you.
Thank you, Nagis. We are ahead of time, so we can take a few more questions. Everyone tired, maybe? Okay, thank you so much.
Thank you.
We don't have our sixth presentation, so the last presentation for today, I'd like to call Roshan Paul to present the talk on plant fossils from the Shivalik group of Vinay Khola section of West Nepal and their significance on hydroclimate.
Good evening, everyone. I am Roshan Paul. I am here to present our research plant fossils from the Shivalik group of the Vinay Khola section, West Nepal, and their significance on the paleoclimate. This is the presentation outline, which includes the introduction, material and methods, result, discussion and conclusion. As we all know that the upliftment of the Himalaya results the accumulation of the mollustic sediment during the middle monsoon to early glaciation in the Himalayan fronts. The Shivalik succession is lies between the main frontal thrust and the main boundary thrust. Plant fossils is abundantly found in the well-dated Vinay Khola section, which gives the climatic condition during the deposition of the sediment. Reconstruction of the paleoclimate and the paleovegetation on the basis of the plant megafossils is still lacked in the study area, so we prefer to do this research. Materials and method. Plant fossils are extracted from the beds of the siltstone and the mudstone from the fieldwork, and they are the present fossils leaves are cleared with the help of the fine chisel, soft brush and the hammer. Then photograph of the plant fossils are done by the digital camera under the low angle natural light. The terminology of the leaf morphology was described by following the digital 1974. The fossils were identified by comparing with the herbarium sheet of their nearest living relatives from the Herbarium of Forest Research Institute, Dehradun, India, and the digital data set of Q Herbarium. Result includes the geology of the study area. The study area includes the mainly the northern belt of the Shivalik, which contains the two formations, that is the Aruncola formation and the Vinay Khola formation. The Aruncola formation is further divided into the three members, that is lower, middle, and the upper, on the basis of the proportion of the sandstone and the mudstone, and Vinay Khola formation is divided into the lower and the middle member on the basis of texture of the sandstone. The red rectangle on the geological map shows that the fossil origin from the middle member of Aruncola formation, and the red rectangle shows the fossil origin from the upper member of Aruncola formation and the lower member of Vinay Khola formation. This is the lithological logs of the fossil origin, BSA, BSP, BSC, and so on. Systematics of the fossils includes the identification of fossils. 14 species of the different types of the fossils are identified, which are Clinogine ovatus. Modern comparable species is also the Clinogine ovatus. Mangifera sumistorica, which modern comparable species is Mangifera indica. Calophyllum sureflaensis. Dipterocarpus species, which modern comparable species is Dipterocarpus macrocarpus. Another one is fruit wings of Soria species, and leaf of Soria shivalica. Andhra and Asti, 1993. Modern comparable species is Soria asamica. Phyllanthus squarensis. Olbigia shivalica, which modern comparable species is Olbigia labe. Bonia species, comparable species is Bonia porphyria. Cyanometra pediorica, which modern comparable species is Cyanometra polyandra, and fruits of leguminocarpon species. Diagnosing mocumensis, which modern comparable species is Cinnamomum comala. Grevia species, which modern species is Grevia disperma. And finally, the Syzygium pelicumini, which modern species is Syzygium bensum. Now come to the discussion. This is the present day distribution of the forest types of the modern comparable species of the fossils leaves of the study area. Which shows that there is a evergreen to mixed deciduous forest during the deposition of the sediment of Auricula formation and the Biacula formation with the warm and humid condition in the tropical to subtropical climate. The distribution of the Dipterocarpus in the modern vegetation shows they are distributed in the Southeast Asia, including Sri Lanka, India, and the Philippines, and now they are totally disappeared from the flora from the Nepal Himalaya, which is according to the Srivastava et al. 2017, the Dipterocarpus presence of the Dipterocarpus from the Auricula formation shows that it indicates that there is a warm and the humid climatic condition and dry season, not more than 3 to 4 months. The disappearance of the Dipterocarpus from the flora of Nepal Himalaya is resulted from the weakening of the monsoon, which was caused by the upliftment of the Himalaya due to the collision between Indian and the Eurasian plate. Conclusion: total 14 fossils, 13 new fossils, leaves, and the fruit wings are identified. They are Clinoginobatus, Mangifera sumastoica, Calophyllum suricolensis, Dipterocarpus species, Soria sivalica, Soria species, Phyllanthus coelabensis, Olbigia sivalica, Cyanometra paleoripa, Leguminocarpon species, Daphnosin mocumensis, Grevia species, and Syzygium pelicumini. The analysis of the present day distribution of the modern comparable species of these fossils revealed that the evergreen to mixed deciduous forest in the tropical to subtropical climate during the middle Miocene to late Miocene. These are the references, and thank you.
Thank you, Roshan. Before proceeding to the question answer, I'd like to inform that we have a small change in our program, so we have one more presentation, so please remain seated. And any questions? No questions? Thank you so much. So our next talk will be the first talk of 9th session of tomorrow by Rajendra Kumar Chetri, titled Revised Liquid Stratigraphy and Paleogeology of the Pokhara Valley, a Scientific Perspective.
Hello. Good evening. I am Rajendra Chetri from Pokhara, and my topic for this evening is the revised stratigraphy of Pokhara Valley, Western Nepal. Pokhara is a unique intermountain vessel in the center of Nepal. It is elaborated in northwest southeast direction. Its valley is about 50 kilometers in length. Its average width is about 5 kilometers. The valley is mainly occupied by post-grade ruptured sediments, weakly strongly cemented by calcareous material. These sediments are the result of major episodes of debris flows occurred along the Paleozoic river originating from Anapura. There were 3 episodic episodes: Kalabar episode, Kachol episode, and Pokhara episode. This is the location of the area, Pokhara Valley. This is the drainage frame of which Pokhara is famous for the lakes, like the present large lakes we have is Hewatal, Lenatal, and Rupatal. research depth, then there exists different stratigraphic classification systems for various sediments. I stated in the table 1. It is necessary to make revisions of lithostratigraphy of the valley sediments, create a geological mapping of the underlying using the scale of 1:25%, and plus there is a very conflicting study about the origin of lakes and types of lakes in Pokhara. This is the works of previous work. This Homan is classified in 3 different sediments, whereas Yamanaka divided into 7 units, but without providing any columnar section or detailed description. So the present study aims at providing detailed columnar section plus detailed description and a brand new classified map. This is the results lithographic Begnas formation, which is the oldest formation in Pokhara Valley. It lies over the Kuncha formation, which is the non-conformity, and the basal bed consists of red soil with some angular class of phyllite and metasandstone. The middle part consists of matrix supported breccia with class of limestone and marble. Subangular to round matrix supported gravel conglomerate with class of limestone are present in the middle section, whereas the top part is mostly conglomerate with class of limestone and marble plus it is matrix supported. This is the photograph. This is the photograph of the Begnas River, which are taken from the ridge between Bhewatal and between Begnas Tal and Rupatal, which is known as Pansbhaiya. The second formation is the Siswa formation, which we call as you can see the yellow marking, which is the basal bedrock, and the top one is the sediment. It lies over the. It is mostly phyllite dominated, well-sorted, rounded to subrounded, weakly consolidated matrix supported conglomerate. The middle part has a yellowish mud layer, and the upper part consists of metasandstone dominated, subangular to subrounded matrix supported, weakly consolidated conglomerate. The top part has soil, but just below that we will find metasandstone dominated, subangular matrix supported conglomerate, and it looks like a lateritic cap, reddish cap type. Talakot formation, we found this name after the Talakot village in the northern part of Pokhara. It is mostly calcareous and matrix supported. You can find pebbles, fabric conglomerate of limestone and marble, and the basement rock lies over the basement rock. Matrix supported fabric conglomerate of limestone and marble at the middle, and even at the top part you will find the same thing. This is almost the new result of which we have classified in as older lake sediment, which we consider as an old lake sediment. The lower part is the light yellowish silty mud, and even the middle part is matrix supported conglomerate with class of predominantly limestone and marble. As we go upper, you can find matrix supported fabric conglomerate class of limestone marble and light yellowish silty mud. This is the photograph of Pursakala formation in contact with Gachok formation, and the height of the Gachok and Pursakala is almost similar, which means this was an older lake segment, and there is interfingering. And another finding was that drilling that of Gachok formation revealed that there was aquifers. Gachok formation, which is the second largest formation in Pokhara, which lies in the type section lies in the Gachok village in the northern part of the. It is densely compacted and matrix supported plus class supported, and there is a classification going on in this because Pokhara is very known for seeing holes, and this happens only in the Gachok formation. The bottom part consists of light yellow matrix supported highly consolidated massive conglomerate, and the middle part is light yellow matrix supported highly consolidated medium sorted conglomerate, whereas the upper part consists of light yellow matrix supported highly consolidated matrix conglomerate. Gachok formation is the panoramic view of the Gachok village and the Gachok formation, which we are with the yellow marking. Now, the largest formation in Pokhara is the Pokhara formation, which was by the previous authors have classified into one. But the recent study we have divided this one into sub-units as the first one of the Pokhara formation we have subdivision, which is the Gagan Gaura formation. This is a conglomerate formation. So the bottom part consists of sub-rounded to angular, moderately sorted matrix, supported granules and pebbles. Great exposure of matrix supported loose sediment containing round to subangular granules of boulders, dominated boulders dominated by calcareous sandy silt materials. And the topper part is a light gray exposure of sub-rounded to angular in sorted silky sandy matrix supported granules of. This is the actually the more older one Pokhara, which is the central part of Pokhara, from ranging from upper north to up to Khairani. And this is the second unit of Pokhara formation called Mardigola, which the type section is in the northern part of Mardigola. Here you can see the difference between the first picture and this one. This one has more smaller class and layering. The bottom part consists of laminated with different class and reddish leaching and with boulders, whereas the middle part is well laminated, cross-bedded gravels, pebbles and boulders are present. The topper part consisting of alternation of lamination, poorly sorted gravels, debris growth. And this is the third section of unit of the Pokhara formation, which we have divided, classified into Tal Khola formation. It is mostly clay type division. The bottom part consists of grey to brown color calcareous clay. The middle part is ill sorted with gravels, and the top part is grey to brown sands dominated with minor presence of silt and clay, and the top layer is the topsoil. This is our Rupakot formation, which is the we have considered as the recently existing extinct lake. This is a present. These are bottom was taken as Vijaypur Khola at the western part of it. The bottom part consists of light grey calcareous cubes, and the middle part is class phyllite and quartzite supported pebbly cover, and the top part consists of light grey calcareous. And the last one is the Changapur formation, which we have done as a deltite deposition, and it is a very small, recently deposited one. Grey silky sand. The middle part consists of grey to brown, medium to coarse grained sand, and the top part consists of class supported pebble and clay. This is the map we have prepared for the two maps of on the left side is on the right side is the quaternary map with 10 units, starting from Begnas to as the oldest and Changapur as the youngest. And on the other side there is a map of lakes of around. In this study, we have classified the lakes into three types. One is paleo lake, which is the red one, which existed even before that sediments arrived, because there was a interrelationship with the Kachok formation of Kushekola sediments. And the bluish one is the existing 8 lakes in Pokhara, and the green one is the extinct lakes starting from the top, the Indi Kola. That is known as Vital also. And from at the bottom of the chart, you can see at the bottom there is a green one. There is a Kumle Kola near Khairani. On the left, you can see there's Bangi Kola Tal, and above them that one is the Sarodi Tal and the Kotre Tal, Vijaypur Tal. So even we have found lake sediments in Hamza also. Conclusion: this is the more recent chart of the present study with the previous authors. The present study concludes that Begnas is the oldest, with Pokhara formation into three formation divided into sub-unit, and new formation is to Kushekola and Changapur. The present study concludes that classify the sediment into 10 lithological units. The Begnas is the oldest and the Changapur is the youngest. The prominent unit Pokhara, the Pokhara formation is subdivided into 3 units. The sediments of Pokhara were derived from the lesser, higher, and the Tethys sediment is the source of their lake. There were 3 stages of lake development can be defined as paleo lake, extinct lake, and existing lake. Thank you.
Thank you, Rajendra. We are on time. We can take some questions.
My name is Achut Koirala. And have you done any dating of these sediments, or you are based your study only on lithology?
not yet ready. I found one fossil in the Kachak formation, but still not ready.
Okay, I think no more question. Thank you, Rajendra. And thank you, everyone. I'd like to thank my chair, my rapporteur, technical support, and all the audience for supporting this session.
To wrap up the session now, I would like to request our convener sir, Professor Kumnaran Kodel, for the distribution of token of appreciation. I would like to request chairperson of this session, Mr. Professor Dr. Lalu Prasad Kodel, to receive the token of appreciation. Thank you very much, sir. Similarly, I would like to request co-chairperson of this session, Dr. Susmita Bhandari, to receive the token of appreciation. Thank you very much, sir. I would like to request Mr. Sunil Lamsal, the rapporteur for this session, to receive the token of appreciation.